Hello, I'm Richard Jelsma. I'd like to welcome you to my Algebra II class. Today's topic is multiplying, dividing radical expressions. My students have an assignment, 6.2, page 199, in their green and white workbook, numbers 1 through 33. First property I want to go over is combining radical expressions products. If the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b equals the nth root of a times b. In other words, we can multiply radical expressions if they have the same root or index. We're going to be working only in the real numbers with these three sections. Example 1, multiply if possible, then simplify. The third root of x times the square root of 2. Notice there is no index or root out front. That means that it is the square root, it's implied. This isn't possible because there's different roots or indices. This one's third root and this is square root, so we can't multiply them. Next example, the third root of negative 4 times the third root of 2 gives us the third root of negative 8. They have the same index, so we can multiply them. The third root of negative 8 is negative 2. The reason that's so is because negative 2 times negative 2 times negative 2 is negative 8. Notice that we can take odd roots of negative numbers in the real number system where we could not take the even roots of negative numbers in the real number system. In those cases we always had imaginary numbers. But we certainly can take the odd root of negatives in the real number system. Okay, one note I'd like everybody to know today is the third root of x squared equals x to the 2 over 3. Okay, 2/3 power. The exponent 2 is in the numerator and the root is in the denominator, so it's power over root. Roots of a tree go down and the root of a rational exponent is also down. So this concept is important in these three lessons. The fifth root of negative 5 times the fifth root of negative 2 equals the fifth root of positive 10. Fairly straightforward. And then we get to D, slightly more complicated example. The third root of 54x to the 10th. We have to make sure we have that 3, that index there. Without it, the problem's wrong because then you're saying square roots. There are no square roots in this problem. So if we prime factor 54, we will get 3 to the third times 2. Okay, if I prime factor x to the 10th, I will get x to the 9th times x. We are arranging it this way because 3 is a multiple of the index root or root, which is 3, and 9 is a multiple of 3. So I want to make these powers have the same power as a multiple of this index or root. So that's why we don't say 3 to the third. That's why we are saying 3 to the third times 2 and x to the 9th times x. Okay, x to the 10th is not a multiple of 3, so we have to break this down to x to the 9th times x. Okay, so the third root of 3 to the third, 3 divided by 3 is 1, so we get 3 to the 1. Okay, we have the third root of 2, which can't come out. The exponent is a 1 on top of the 2, which is too small to come out when we have third roots. 9 divided by 3 gives us 3, so we have x to the third coming out. And the third root of x also cannot come out because the exponent on the x is only 1. Now please note, this 3 is a coefficient, this 3 is an exponent, and this 3 is an index. So the size of the 3 matters. Notice that 3 times the square root of x does not equal the third root of x. This is a large 3, so it's a coefficient, and that's a small 3, so that means it's a root or index. Be careful on the size of the 3 that you make or the size of the coefficient or index that you make. It matters. Example 2a, the third root of 128x to the 7th. Okay, if I prime factor 128, we will find that it is 2 to the 7th power. Okay, but since I have an index of 3, then I want to write it as 2 to the 6th times 2. 6 plus 1 makes 7. 2 to the 7th is 128. And this x to the 7th we're going to write as x to the 6th times x. Do not leave off your third root or your index. 6 divided by 3 is 2, so we have 2 squared. Okay? The cube root of 2 we have to leave inside. 6 divided by 3 is 2, so we have x squared coming out of the radical, and we have the third root of x still left inside. So we have 2 squared times x squared times the third root of 2x simplifies to 4x squared times the third root of 2x. Final answer. Cannot be simplified. We'd like to make sure that this answer is correct, so I'm going to put this back inside the radical and see if we do get third root of 128x to the 7th. Since I took the cube root to get this 4 out, I cube it to put them back onto the radical. 4 times 4 times 4 is 64 times 2 gives us the 128. X squared going back under. 3 times 2 is 6 plus 1 is 7th. So therefore 4x squared times the cube root of 2x is equal to the third root of 128x to the 7th. They're mathematically equal. This problem is completely simplified. Next example, we have the square root of 20x to the third. When we prime factor 20, we find that it's 2 squared times 5. X cubed is x squared times x. We're taking square roots. 2 divided by 2 is 1, so I have 2 to the 1. 2 divided by 2 is 1, so I have x to the 1. And we have the square root of 5x left inside. These exponents on the 5 and the x are only 1s, and they're too small to come out of the radical. So our final answer is 2x times the square root of 5x. I want to make sure that this answer is right as well. I must square the 2x to put it back under. If I square 2x times itself, I get 4x squared times 5, which gives us 28x to the third power under the radical. So I realize this answer is mathematically equivalent to this answer, but it's completely simplified. Last example on the multiplication, the third root of 81x to the third. So the third root of 81 is 3 to the fourth, but we don't want to write it as 3 to the fourth. We prefer to write it as 3 to the third times 3 so that these index and this exponent match each other. Still have x to the third, have to copy that. Third root of 3 to the third is 3. We still have the cube root of 3 left. 3 divided by 3 is 1, so we have 3x times the cube root of 3 for our final answer. Okay, for the next property or concept we're going to discuss is combining radical expressions, quotients. If the nth root of a and the nth root of b are real numbers and b is not 0, because we can't divide by 0, then the nth root of a divided by the nth root of b equals the nth root of a divided by b. So we want to simplify the following problems. Simplify the following quotients, rationalize all denominators. We have the square root of 500 over 5. Now our objective here is to make sure we leave no fractions inside of radicals and no radicals inside of a fraction. So I have a fraction under a radical, I can't leave it that way. 500 divided by 5 is 100. So we have the square root of 100, and square root of 100 is 10 for our final answer. Completely simplified. Okay? Now I do not want to put square root of x over 2 inside of a fraction. There's no way I can simplify it, so that would be pointless to create one fraction from this because there's nothing I can do with it. So the only thing I can do is rationalize this. And when we talk about rationalizing the denominator, what that means is we have to remove all radicals from all denominators. So since I have a square root of 2 in the denominator, I'm going to multiply it by the square root of 2. And it has to be a form of 1 so that I don't change the value of this expression. So I must put the square root of 2 over itself. Any number over itself creates a 1. So 1 times this expression does not change the value of that expression. I can't multiply an expression by anything else without changing its value. So I multiply this by the square root of 2 over the square root of 2. And the numerator becomes the square root of 2x. The denominator becomes the square root of 4, which is 2. Finally, we have the third root of x over the third root of 2. We don't want to put these together because we can't simplify them if we do, so we're going to leave them as separate radicals with a fraction bar between them. The only thing I can do is rationalize this denominator. I have the third root of 2 in the denominator, and I cannot leave that down there for my final answer that in that form. So we're going to multiply by the third root of 2 squared. I have a 1 that's implied here, so I need 2 more to make 3. So it's the third root of 2 squared. I put it over itself, so that's why it's a form of 1. So this way we have the third root of 4x in the numerator. In the denominator we have the third root of 2 cubed, which is 2 in our denominator. So this is our final answer. And it is simplified. Example 4a. We have the square root of 18x to the fifth divided by the square root of 2x to the third. This is a case where if we create one fraction out of the two radicals, we can simplify it. So when that occurs, that's what we would like to do. Make it into one fraction so we can simplify. So this gives us a square root of 18x to the fifth over 2x cubed. 18 divided by 2 gives us 9. We have the square root of 9. And 5 minus 3 is 2. So that gives us x squared. Square root of 9 is 3. And 2 divided by this implied 2 gives us 1. 3x is our final answer. The next one, we have the third root of 15x squared over the third root of 5x. Again, because this will make a fraction that we can simplify, so we want to put it inside the radical in the form of one fraction. So we have the third root of 15x squared over 5x. This gives us the third root of 15 divided by 5 is 3, and 2 minus 1 is 1, so I have the third root of 3x for our final answer. It is simplified. C is another one that if we create one fraction under a radical, then we can simplify it. So we have the third root of 48x cubed y squared over 6x to the fourth y. Make sure you have this index. If you leave it off, you're talking square root, and that makes it wrong. We have no square roots in the problem. So this still has a third root. 48 divided by 6 gives us 8. Okay, 3 minus 4 is negative 1. So if you remember your rules from Algebra 1, your exponent rules, you will have x to the negative 1, but we can't have a negative exponent, so we move it from the numerator to the denominator, becomes a positive 1. So 8 over x, and 2 minus 1 is 1 for the y. So we have the third root of 8y over x. Now we would be finished with this problem were it not for the fact that we have a fraction inside a radical. We can't leave it that way. But since we have simplified as far as we could, we're going to go ahead and split this apart again in order to rationalize. So the numerator becomes the third root of 8y divided by the third root of x. Third root of 8 is 2, leaving us a 2 times the cube root of y. And in the denominator we still have the third root of x. We cannot leave this radical in the denominator in our final answer. So therefore, we must rationalize. This has an implied exponent of 1, so we need 2 more to make 3. So we're going to multiply by the third root of x squared over itself. That way it's a form of 1. Okay, outside there we have only the coefficient 2 carried over. And we have the cube root of x squared y inside the radical, cube root of x squared y. In the denominator we get when we multiply these two terms together, we have the third root of x cubed, which is x, for our final answer. So the last example for today's lesson is the third root of 14 over the third root of 7x squared y. Because 14 will divide by 7, I would like to create one fraction, and I get the third root of 14 over 7x squared y. So that gives us the third root. 14 divided by 7 is 2, so we have 2 over x squared y. Alright, so that gives us, cannot be simplified anymore. So that gives us this expression down here, the third root of 2 over the third root of x squared y. Since I can't simplify it anymore, we now split it into two parts again, a radical over another radical. So we have the third root of xy squared over the third root of xy squared that we need to rationalize this. Now, if I don't have third root, I can't multiply them together, so that's why this has to be third root. And that power is a 2, so I need one more to make 3. So that's why this is x to the first. And this is y to the first, and I need 2 more to make 3, so that's y squared. Now I have to put it over itself, and that way it is a form of 1. So the third root of xy squared over the third root of xy squared. We're going to now multiply these together. So we have the third root of 2xy squared. Nothing can come out. All the exponents inside this radical are less than 3. And in the denominator, we have the third root of x cubed times y cubed. 2 plus 1 makes 3 for the x, and 1 plus 2 makes 3 for the y. We can't simplify the numerator any further, so that leaves us with the third root of 2xy squared, and in the denominator, the third root of x cubed, y cubed becomes xy. The answer is simplified as far as we can go, and thank you for tuning in. Bye.